So thanks for coming this evening. My name is Hugh Halper-Thompson, co-founder and CTO of BTL Group. Just before we have our speakers on, I want to give you an introduction to who we are, what we do, as well as the as well as the format for this evening. I'm going to give an introduction to blockchains, what they are, roughly how they work, and specifically what business features you can pull out and how you can apply that to existing industries. And then we're going to do a deep dive with our two speakers this evening. So, I've been involved in the blockchain space for about 5 years now. I started this company with my brother Guy, who's based in Vancouver. BTL builds products and proof of concepts in the payment space, as well as offering educational events and workshops. We've got a live blockchain network enabling payments between Canada, Mexico, and the Philippines. That's got real client money going through that right now. And we're working with major financial institutions and banks to enable interbank payments on our scalable proprietary network. Just a quick history of the technology and where blockchains came from. They're more out there. No, that's better. Cool. Right. So yeah, just a quick history of where blockchains came from and how they work. Bitcoin was really the first blockchain. It was a combination of several technologies. It brought together areas from cryptography, from distributed ledgers and databases, and it added this game theory layer on top, so this consensus layer on top of it. Bitcoin was only the beginning. It enables the transfer of value, transfer of Bitcoins effectively from one person to another. As Bitcoin grew, it encouraged a whole wave of innovation in cryptography and fintech. The first big change that everybody saw was Ethereum. Ethereum turned the platform supporting transfer of a single asset into a general purpose programmable blockchain. They in turn created a whole wave of innovation, a whole new wave of innovation, and today most, or certainly many of the blockchain networks you hear about in enterprise and in banking are based initially on what Ethereum launched. So some of them are still very close to what Ethereum put together, some of them have forked out slightly wider, but a lot of that base technology has followed this history. First question everyone always asks is, what is a blockchain? This will be, some of you will have seen this already, but for those of you who haven't explored the technology yet, a blockchain is literally a chain of blocks. That's where it gets its name. Each block points to the previous block, and if you modify any of those previous blocks, that breaks the chain. So that's very important because it means data cannot be changed without changing the state of the entire system, and therefore everybody knowing about it. Each block contains a set of transactions or a set of data, which has been appended to the ledger, and then blocks are appended to each other at set time intervals. As each block is issued, it's added to the chain of existing blocks, creating a blockchain. So how does it look when it's deployed across a network? There's various types of there's various ways you can deploy blockchains. There's public blockchains and private blockchains. The two biggest public blockchains that people use at the moment are Bitcoin and Ethereum, that I've covered slightly. This is an example, if you can see the image on the right, of various banks, or it could be different institutions in any industry, deploying a network, a shared ledger network between each other in that industry. So if you've got a network of banks, everybody's got a shared copy of the same ledger. They're looking to keep all their ledgers in sync with each other. And this means that every bank can verify all the data that goes into this ledger. Now on this sort of network, banks don't need to arrange complex correspondent banking relationships. They can settle directly with any bank in the network. Now, combining various technologies, you can provide full transparency to say, a regulator or an issuer or somebody operating the network at the center, and you can also provide full privacy between all the participants. This is important where transactions contain sensitive data. So unlike the first blockchains, Bitcoin and Ethereum, which only processed a few transactions per second, blockchains now are scalable, or certainly our blockchain, some other blockchains are scalable through traditional means. So we've got we can scale using standard techniques. This really opens up a lot of new use cases that are being put together today. So the use cases are really endless, and I can go on all day about them. But to pick out a few, certainly a few of the features, when you enter data into a blockchain, if the data is immutable, that means once it's in, no single party in the network can delete it. Blockchain acts as a witness to an event, providing a perfect auditable record. So whether that's in a regulated environment where an auditor's job, for example, would be to go in, there's all sorts of things they've got to do with, when they go in and check a firm. But one of the first things they do is check, is the data that this firm is giving me, is it accurate? Have they gone and fiddled with the books and tried to hide the things that have been going on? So with a blockchain, that's completely a thing of the past. You can trust the data that's been in it because you cannot go back and change it. Participants in a blockchain can trade assets without trusting each other, they can trade data without trusting each other, and without having a prior relationship between them, and also without having a central party that they have to give up commercial control to. So a blockchain deployed across multiple organizations enables a shared copy of the truth without a central party. Reconciliation can be a thing of the past. I've witnessed companies of various sizes dealing with reconciliation issues, which are effectively, in a simple example, if I lend £50 to someone and then I get the money back the following week, when they come to pay back, was it 50 quid, was it 40, was it 100? If nobody really remembers, we've effectively got different ledgers in our heads, and we've got to try and work out, okay, what feels right, what are we happy with? Now I've witnessed that conversation where two companies are trying to work out, do I owe you 1.2 million, do I owe you 1.4 million? And these companies are negotiating on either side where neither party actually knows where they're meant to be. It can be a huge problem. It also enables the trading of cash or shares or any asset with value, and between trading organizations, and data like healthcare records can be guaranteed to be in sync between various silos that hold these records. So anywhere where you've got records that they're effectively falling out of sync with each other, you can put those on a blockchain without changing the structure of that industry, without appointing a central party, and you can make sure that everybody has the same data. Smart contracts, I'm not going to go too deeply into right now. I think they'll be covered slightly later on. But there's a whole world of use cases that are opened up through smart contracts, and I expect a lot of what hasn't been thought of yet to be leveraging parts of this. So blockchains enable new ways to trade, new ways to trade assets in ways that have never been possible before. This is going to have a huge effect in financial services. It's going to affect middlemen from exchanges, clearinghouses, peer-to-peer lending companies. The efficiencies and cost savings should open up access to not only people who are currently priced out of financial services, but also banks and smaller banks and credit unions who are effectively don't have access to the wider payment networks. In the immediate term, I think the first deployments are going to be in the coming year or two are going to be small payment systems, smaller payment networks between a small group of banks. But once that goes live, it's going to expand very, very quickly. Blockchains enable us to share data among untrusted parties without a controlling central party. It's going to have a huge effect on regulatory reporting, it's going to have a huge effect on auditing firms, and it really changes the way, it removes part of what you need to do as an auditor, in that you can trust the data that you're given. This because blockchains really give you the perfect witness to an event. So this means notaries, for example, can be a thing of the past. Identity management, from KYC to the way passports and identities are issued, can change completely. So really, to sum it all up, blockchain is going to make a huge difference in several ways in the ways we do business. Why are blockchain so important? Well, stepping back slightly, business is based on trust. The way we interact, the way we trade, it's all based on trust. Now, the internet enables us to communicate, and it does that very well, but it doesn't enable that trust. So blockchains allow people to trade with each other with no prior relationship and no need for that trust. It allows market participants to trade directly without changing the structure of their market and appointing a central party. So this literally can redefine the structure of industries. You've got industries in countless areas, from finance to healthcare to all sorts of areas, where the entire industry has grown up around the idea of a central organization that has to hold all that data, because there's no way for people to keep access to a single copy of the truth, a single record, without appointing an owner of that process. So blockchains are really giving us the internet of trust, and they're going to change the way that industries are structured. So thank you very much. Are there any questions right off?
You contrast the permissioned and permissionless blockchains. Are there any options in between?
So in terms of the different blockchain architectures, the question was, there's permissioned and permissionless blockchains. Is there anything in between? So there's various hybrid models depending on what use case you're going with. A fully public blockchain or permissionless blockchain is fully open access, and people can take part in any way they want. So the big examples of Bitcoin and Ethereum. You can have a fully closed network where you've got a group of banks, a group of NHS trusts who firewall off a private network between them. And you can kind of have hybrid models. So we've done some work with in the gambling space, for example, where you can have a private model between the gambling companies, who are the only people able to transact and to issue data onto this network, but then you can open it up to the wider public who can audit these companies and basically make sure that they're not changing the odds after they've been issued, after people have specs and things like that. So there's all sorts of options depending on the use case.
I think it will also completely modify the way we see SSO, technically speaking, in single signer in different ways. So this is something as well that is important to consider. You can authorize a machine to talk to another machine, or a software to talk to another software, a person to interact with something with specific conditions as well, and authorize, deauthorize, reauthorize in different ways. So those use cases are not there yet, but they're completely available and doable today. You just need to be thought through for the right use case, with the right business workflow, and the right techies to code it, and off you go.
Questions?
I'd imagine the hack on the DAO will affect the development of Ethereum.
I've almost got bets on how long it's going to take. The DAO, for those of you who don't know, stands for Decentralized Autonomous Organization. It's an investment fund, effectively, that was created on Ethereum, on the public network. And it raised, at its peak, I think it was $220 million. So there's a lot of money in there. The DAO was hacked. Somebody effectively threw a bug in the code, which was specifically the DAO code, which is an application that runs on top of Ethereum. That enabled a certain hack. There's a lot of discussion over what to do about it, whether people can react or not, which I'll leave the discussion for another time. But certainly in terms of the technology, it's opened up a whole load of questions in terms of how we do security audits on fully public smart contracts. But in terms of a private network, for example, if you've got various banks, if you've got various NHS trusts, if you've got any situation where we know who all the different participants are, there is a permanent record that this participant stole these funds, did something they weren't meant to do. So in a private network, in effect, it doesn't matter because you can roll it back. There's repercussions, the legal and court repercussions in the normal sense. On the public Ethereum network, it's a wider question, but one thing that has come out is the core technology of Ethereum hasn't had any issues through this. And really it shows the core technology is solid. What you build on it, people have got to be careful around how they code it.
Just going back to your sort of reconciliation point. So I guess in a world where there's one blockchain and everything is on it, there's one source of truth, there's no reconciliation. I imagine what we're going to have, you've got a private blockchain for payments, Barclays are going to have one, we're going to have 50, 60, 100 in the next 5 years.
We're going to have millions.
Yeah, whatever, as many, as many as we want. So are we going to end up reconciling all these things and just putting it all in an Oracle database anyway? So, I mean, I understand the one version of truth, I think is a really powerful thing. But, the fact that I talked to someone at the bank and they said, let's have one blockchain per client. I think people need to be, how do you see that working?
If you step right back to that single version of truth, if there's two people interacting and you need a single copy of the truth between those two people, if you put it on the blockchain, they've got a single access to those records, but they still, if there's a dispute, the only people who've got a copy of that is, say, it's me and you. So if we're going to fight about what that data is, we can both edit our local copies, and we still end up fighting about it. If you've got more than two organizations, everybody ends up holding a copy of the data. So effectively, unless you can bribe everybody else in the network, so whether it's all the banks getting together and or whether it's in various situations,
it's called,
it makes it a lot harder.
LIBOR and that sort of thing.
Oh, there's things like that, but if you had it between banks, you'd have the regulator involved as well. So
if he understood it.
Open question.
Anyway, but my question was not on that level. My question was on the fact that a really boring operational question, not about collusion or anything like that. If I'm an auditor and I'm substantiating the balance sheet of a company and you've got 50 blockchains, okay, so I have 50 sources of truth, but I have to pull that together. And in some ways, that's what most of corporate enterprise systems are doing today. That's where all the horrible money, time, effort is wasted. So, this vision that blockchain gets rid of all that, I think it gets rid of lots of micro things, but how do you see it operating on a macro level like that?
So you've got, currently say you've got 20 organizations, they've each got their own system, they've got a siloed copy of these different, say, medical records in hospitals. And the hospitals have a copy, doctors have a copy, pharmacists have a copy. And you could have a blockchain for medical records or for a specific use case. Currently, if they're out of sync, they've all got these different systems. If you put in a central party, that changes the commercial relationships between them. If you put a blockchain over it, they've all got that same base copy, so that makes that piece far more efficient. So you can, if you're trying to put out where there's various blockchains within the same organizations and you want to audit the whole lot, you can pull that up. There's ways of doing transactions between blockchains. There's various methods now and others being researched. And you can pull that up to a sort of master level within your organization or to the wider public networks. There's different ways of structuring that. If that answers your question.
Take it off now.
Hey, I think last question just for...
Just trying to understand something. Am I right in saying that on a public blockchain you wouldn't have privacy as a region on your transactions, or? So
on a public blockchain, can you have privacy? Yes and no, sort of. It's a perfect answer, but everything that happens on a public blockchain, all the data that goes in is fully public. So everybody in any blockchain can see what goes onto that chain. But there's various ways of encrypting that. There's various ways of hiding bits of that data. You may want to say who you are, but not show exactly what you're transacting. So as long as the parties involved in the transaction know about all the data, so they need to know everything. But you don't necessarily need to give all that up to everybody else in the network. So at the base of it, the data on there is public, but there's various ways through standard cryptography to hide that.
Can you hear me? Good evening, everyone. My name is Jess. Thank you. I'm from Everledger. And Everledger is a non-financial use case of the blockchain. So I'm going to talk to you this evening a bit about how we use blockchain technology and also a bit about the diamond industry. So what we do at Everledger is we use blockchain technology to solve big problems. And the problem we focus on is problems. So if you think about this word, what this word means, it means where slides are going ahead of me. Where does something come from? Where did it go? Who owns it? Who bought it? And where is it now? So in the world of luxury goods, provenance matters because you cannot separate the value of an item from its provenance and its history. So it's to diamonds, to watches, to jewellery, and to luxury goods. But we have a fundamental problem. The world's provenance is locked in paper. You go to a store, you buy a watch, you get a paper receipt, you take it home, and for anyone like me, you lose it. And when provenance gets lost, a new word emerges, risk. So risk is the foundation of our biggest black markets. Firstly, theft. I'm sure you all heard about last year in Hatton Gardens, London's Diamonds District. These guys broke into 72 safety deposit boxes and stole over £200 million worth of diamonds, watches, jewellery and cash. And ultimately, when provenance is lost, crime pays. So secondly, the second market is fraud. So what's stopping me from going into calling my insurance company and saying that watch has been stolen when it hasn't, and ultimately I sell it on 6 months later. And finally, cyber. We could all be being hacked right now in this room and none of us would even know. Okay, so these problems are real, they're quantifiable, and they cost insurance companies $50 billion annually. Well, not only that, they cost every single one of us in this room increased insurance premiums. So we created Everledger. It's a digital global ledger that tracks and protects items of value. And we're on the blockchain. And we're on the blockchain for 4 main reasons. Firstly, it's immutable. Secondly, it's secure. Thirdly, it's fast. Finally, it's scalable. Okay. So we started with diamonds, and let me tell you what we did. So we created relationships with the 4 major certification houses around the globe: Israel, Antwerp, America, and India. We took 40 metadata points from across the stone, and we took the 4 main C's: cut, clarity, colour, and carat. And we linked all these to the laser inscription on the girdle of the stone. We took all this information and we wrote it into the blockchain, and we created a digital thumbprint. This enables us to track diamonds that are sold and resold on online marketplaces such as eBay and Amazon. And we can now use this information to work with insurance companies on fraudulent claims. We work with Europol and Interpol on diamonds entering black markets. And we can also work with banks and insurance companies financing the diamond pipeline. And we do all this via our API system, so we can track where stones are resold and also where they end up. So, we're part of the Barclays Textiles Accelerator, so we're located just next door. We're part of the March 2015 batch, and we onboarded during that time 500,000 diamonds. We're part of the Alliance Accelerator in France, in the heart of luxury goods. And we also work with Aviva globally from their digital garage in Hosmer Square. We work with Barclays in Africa, where 65% of the world's diamonds are still mined. We work with Commonwealth Bank in Australia, and we work with BBVA in Spain and Latin America for compliance matters. So we now have almost 1 million diamonds on our blockchain. And I'm just going to tell you now a bit about the diamond industry. So the diamond industry is built on a chain of trust. It's a 150-year-old industry. Most of the families that established it still work in the market today. However, there are some serious flaws which I'll talk to you about, which Everledger is trying to solve. So if we take a look at the diamond value chain, when diamonds come out of the ground, they're valued at $15.2 billion. By the time they hit the cutting and polishing houses, they're now valued at $47.2 billion. And by the time they hit the retail market, before it's even been set into a ring, they're worth $72.1 billion, which, as you can see, is a huge industry. However, there are some shortfalls. So, the diamond industry loans around $20 billion a year. However, I don't know whether any of you saw recently, Standard Chartered a couple of weeks ago announced that they're actually going to cut their funding to the diamond industry due to risk mitigation. So there's a shortfall of around $3 billion. Okay, so what we're looking to solve really, and Everledger is going to help in this industry, is firstly fraud, mainly in B2B and B2C markets. synthetics, which have been peppering the pipeline, which I'll talk about later. And also conflict zones. I'll talk about Kimberley process in a short while and how we're kind of enabling that digitally. And also double financing. This is where stones are loaned against not once but twice because there's transparency in the market. So basically the Kimberley process was established in 2003 and it reduced blood diamonds by around 23%, which is extremely impressive. However, these guys on the borders, they only have an embossing stamp and a fax machine. So as you can imagine, there's a lot of room for tampering around there. So also the Gemological Institute of America was hacked last year. They grade and certify around 70% of the world's diamonds. So 2 people were arrested, 12,000 documents were tampered with, and what they did is they amended the colour and the clarity of the stone. So these diamonds are now in marketplaces all around the globe, but they're unidentifiable. And last year, HRD in Antwerp announced a laser removal service. So the laser inscription that I mentioned earlier on the girdle of the stone that lets us track all the diamonds, they came up with a great idea to remove that. No one's really sure why, but that now enables people obviously to go to one certification house, have a laser inscription on the girdle, get a genuine certificate. They can then have their number digitally removed, laser removed. They could go to another certification house, get another genuine certificate. They could basically multiply the amount of genuine certificates they have, and they could, instead of selling the genuine diamond, they could sell synthetic ones, for example, or completely different ones. And synthetics. So synthetics have been around since the 1950s, but when they were created, they were actually just created for industry, for cutting and sawing. But recently, they've become very popular, and they're now gem quality, and they're grown in 3-story buildings around the globe. Also, quite interestingly, Leonardo DiCaprio, after his film Blood Diamonds, actually invested in a synthetics company, which is really called for more transparency around the genuine diamond market, because it does raise an issue where you can say, my diamond is completely ethically sourced, it was grown in a lab in China over 2 years. You really need to know where your stones come from. It's really important to know there's not a blood diamond on your finger. So controlled environment. So the diamond industry actually is a very controlled environment. A lot of the labs actually have biometrics and actually iris scanning when you go into them. So there is certainly ways that we can look at bringing this technology onto our blockchain, and a lot of that is to do with IoT, which you mentioned earlier, Hugh, actually, and connected devices. So, for example, the devices that synthetic diamonds, you can't tell through the naked eye whether it's a genuine diamond or it's a synthetic diamond. You need microscopy. So these devices used to cost around $20,000 US. They were this big, immovable, not portable. They're now around $1,000, and they're nice and small, and you can move them around. And all this data at the moment, it's ready to be IoT enabled. And as soon as that happens, we can take all this information and lock it into our blockchain. And we can also add that to the history of every stone. Okay, so high definition photography. So I mentioned earlier, HRD created this lovely service that you can remove the laser inscription on the girdle of every stone. But what we do at Everledger, I mentioned we take the 40 metadata points, we take the 4 Cs, and we also take a high definition photograph which captures the inclusions in the stones, which you can see just here. So actually we don't need the laser inscription in Everledger. We've actually found a way around this. It does help, it's nice to have laser inscription on the girdle, but that's the way kind of high definition photography is moving forward. And I mean nowadays, they're talking very soon that you'll be able to take photographs of this quality with just your iPhone. Okay, so that's today, and in the future, where we're looking at the blockchain to help and move forward, we're looking at notarization and timestamping, ownership and title transfer, chain of possession, and systems of warranties. So at Everledger, we started with diamonds. We will be moving to jewelry and fine art. We're looking to luxury goods, which is not just a $50 billion problem, but a $1.7 trillion problem. And also in ethical sourcing, I think, with the issues that are happening in Syria at the moment, all these archaeological objects that are entering into bonded warehouses, etc. There needs to be some transparency around those objects and where they came from. So Everledger, we're building the digital vault of the future. Thank you. Does anyone have any questions? Oh, I'm going to stop that. That's just an appendix. Yeah?
Where do you store your high definition images?
On our blockchain.
On your blockchain?
On our blockchain.
Which is the main top of the blockchain?
So basically we use BigChain DB and we also use Bitcoin because when we established the company just over a year ago, Bitcoin really was kind of the blockchain out there. And we use that as our database, and then we use Ethereum as our smart contract profile. And then on top of that, we've got our Everledger, which we've got at the top. So, yeah.
So you have an API which allows you to interact the houses, the merchants to interact with your Everledger.
Yes.
That is something which they have to install at their site, and that's privileged access, right?
It is, yeah. So we work directly with everyone along the pipeline.
So if it is a dumb question maybe, right, how is it different from creating a shared database of all diamonds and all parameters?
That doesn't exist, at the moment. And I think so our CEO, her background is emerging technology and also the diamond industry. And what she saw was when she saw the diamond industry, everyone works in silos. There is no shared database. If you talk about cutting houses, for example, when I mentioned that they can literally take a diamond, have the laser inscription moved and go from one certification house to the next. That information is in silos, however we can utilise that API system to transfer.
So just my final question, right? So from a technology perspective, you chose blockchain over say a database.
Absolutely.
What was the reason for that? Because if I have to install APIs at client side, I can do that with the database as well.
Yeah, absolutely. I mean, a lot of it to do with immutability. It is the fact that it's cryptographically signed, that it's fast, it's scalable. They were the main reasons that we use it. Yeah.
Do you mind just telling us your story and where you are now in terms of your company? So how many people, how many developers?
Yeah, absolutely. So I mentioned we're just over a year old. We have 2 engineers. We are just onboarding developers and UI UX designers as we speak, actually, they're being interviewed. We've got 2 business developers, 2 business analysts, PR, admin, which is a hell of a lot of admin. We've got Leanne, our CEO, who goes on the globe. We're actually coming into our Series A at the moment, so we've got a couple of people working on that as well. So we're about 12, I think, at the moment, but we are growing rapidly, and I think there'll be a lot of we partnered with a company about 2 months ago called Starry, who's actually based just over here, to grow our business. And we're currently looking, we just finished the MasterCard Immersion Week, and we're partnering with them and looking at warranties and luxury goods in that market as well. So, I think one of the great things about Everledger is Leanne is such a spokeswoman. Her background is tech. That's her love and her passion. So I think it's been interesting over the past 5 months. People have actually just, they've gone, blockchain, what is that? How can we use it? They found out a bit more, and they've gone, who can we talk to about this? And they've actually just reached out to Leanne. We're fortunate that they've linked in our emails, and there are a couple of projects that are certainly in the pipeline that may not be based on asset classes that you'll find out about in the next few months.
Have you traced any stolen goods so far?
Yeah, well, stolen is an interesting word. We used our APIs, and we did do some tracking, and we did call about 120. We basically, it's difficult to say. I can't disclose too much information, but yeah, we did. We found around £2 million worth of fraud. But that was various across certificates, whether they were duplicated certificates, whether they were fake certification houses, GAI or GI Industries, etc., etc. We did, so yeah. Yeah.
In terms of the business model, who actually will pay you in the long run for the service? Is it the cutting houses or the
It's everyone on the pipeline, but it is data aggregation. That's essentially what it is, and also people look into our APIs and our information. But it's insurance companies and banks
So they pay you for access to the data.
Exactly, exactly. Okay. Thank you.
Well, I might not actually be giving you quite a deep dive, as I think I was advertised as doing. What I would like to do is take you through our approach to blockchains in the energy space, and perhaps give you a little bit of our rationales, and hopefully perhaps even engage in a conversation about why we think blockchains are particularly appropriate for the energy business, and what could be done in the energy business that will benefit from blockchains. So let me just start with a quick thought. If I enter into a contract with you for the supply of a service under a defined contract, why is your invoice any better than something I can calculate? Particularly with energy. I've got my meter in my cupboard. I know how much energy I've used. If I can do the calculations based on the price, I should be able to work it out. So why is it that an energy supplier can report me to a credit reference agency claiming that I haven't paid when I know I'm not owing that amount of money? Why can they give me all this hassle? Why have I got to deal with these problems when they're the ones who are at fault? And if you think this is an academic argument, it most certainly isn't. There have been, in fact, almost no weekend goes by without the weekend newspapers reporting on the latest terrible problem with one of the energy suppliers. This one I quite like. This one was actually the energy ombudsman, who was sent a bill for £1,400, which he didn't owe. And when he complained, knowing full well what the complaint procedure was, he didn't get a satisfactory answer in the right time, so left in the difficult position of actually complaining to himself, which he didn't end up having to do because he actually called the chairman of Empower, who he happened to know, and got it sorted out that way. But we're not all in that position. So really, that's my starting point. Is what we're trying to do here, as I'll try and bring out, is trying to level the playing field. Now, if you think these are just a couple of isolated ones, and that it's not really a big problem, then I'd like to point out some of these recent finds. These are all in the last couple of years or so. But you just need to go onto the Ofgem website and have a look at, just type in "find" in the search bar, and you'll come up with a whole slew of them. And they're caused by problems very often innocently done, but things like the wrong bills being sent out, the complaints procedure not being followed correctly. In some other cases, there might be rather more obstructive mechanisms being put in place and thrown in front of people when they're trying to switch electricity supplier or gas supplier. And these are the kind of things that are problems that consumers have to deal with. So back to this theme of what would we like to be able to do about this is to create a level playing field, and this is specifically what Electron are attempting to do, is create a level playing field for everyone from the smallest consumer all the way through to the biggest supplier. And we will do that with a blockchain. Let me just back up briefly and ask the question: why would we want to do energy? What's the attraction of that? Well, first of all, it's not banking. Bankers have pretty deep pockets. They are well aware of the fact that they've got a lot to lose with blockchains. It's one of the fundamental things that a banker does, is provide himself as a custodian of record. This is really, in the energy space, is something that will improve the market for everyone, but is not a fundamental part of generating or consuming electricity. So therefore, it's an attractive space for us to be in, and it's one in which I think we can make a strong contribution. I would argue that the sort of things that make a good market for blockchains, and I've put a list here, these are not the only ones obviously, but I'd say that any market in which there's a provision for some kind of ongoing service, where a lack of trust in market participants is the case. where there's a commoditized product that's supplied by competing producers under predefined contracts which can be switched, and preferably switched electronically. Those are the kind of characteristics which I think make a market which is highly suitable for blockchains, and particularly if there's an imbalance in the power between the supplier and the consumer. Okay, so perhaps there might be some other markets that look like this. I've put up a couple there, and actually, interestingly, the water market, you might think, I mean, the actual supply arrangements and the regulatory arrangements in the UK, at least, in the water market, make that difficult, but actually that is now being opened up. So medium-sized consumers of water will start being able to choose their supplier. Broadband fits that specification as well, as do mobile phones. I certainly don't know if I'm on the best mobile phone contract. I'm sure nobody else here does either. But it would be great if we had some mechanism whereby that switching could take place, and ideally, if there were some mechanism that I could be empowered to use as a consumer that would allow me to analyze perhaps my data usage, for example, in mobile phones, my gas and electricity use in the case of energy, and allow me to then optimize that. Again, trying to level the playing field. Okay, so what are we going to actually try and do with Electron? This actually is a fairly shameless reworking of Vitalik's very sensible articulation of the problems that blockchain can solve. And I'm trying to address this towards the energy sector. So the first thing really is oversight. It provides a mechanism for complete transparency in virtually real time, something which you just don't have currently in the retail market in energy at the moment. Cost. Any kind of central monopoly running a record-keeping system tends to be relatively inflexible and expensive. Bankruptcy. Energy suppliers do or should be able to go bankrupt, and they do and have done in the past occasionally. That's a big problem. You know, you have to get inside the supplier's building effectively. You have to see who all of the customers are. You have to work out what their outstanding balances are, assuming that all of their record-keeping systems are up to date and so forth. If that's all sitting on a blockchain, then that isn't so much of a problem. In fact, you could then be switched pretty much immediately to an alternative supplier. Incompetence. We saw that, I gave the example of TalkTalk, but Electron, or the Electron platform, of course, based on when we use the Ethereum blockchain, provides the kind of security guarantees that an Ethereum smart contract provides. The other big benefit, I think, is it reduces barriers to entry. A decentralized platform where effectively the ability to write smart contracts and to deliver services on that platform is costed at the marginal cost of the gas cost of being able to deploy those contracts, is a lot lower barrier to entry than perhaps a big database that you're having to pay the access to of a monopoly supplier of, for example, smart meter data. In the case of the energy market, there have been a number of problems, largely clamped down on now in the retail market, but still persisting in the small business market of rogues and rogue switching. And it's hard to see, except in retrospect and when the bills start coming in, whether or not somebody's actually been moved from one contract to another, when in fact the contract they were moved to was much more disadvantageous to them than the contract that they were currently on. And again, transparency through a blockchain can provide effectively immediate notification that that's the sort of thing that's been going on. Complaints. There is a big problem with complaints. I'm sure a lot of people here have been involved in those with their own energy suppliers, where complaints are fundamentally a problem of the billing systems. And again, if that billing system, or a portion of it, is verified and put through a blockchain, then you have a single record, as we've heard earlier, about how that is then tracked and reconciled. Let's quickly move into a little bit more specific detail about the energy market as it currently is in the UK. Back in the 90s, there was a deregulation of the energy sector in the UK, and the idea at that point in time was to bring in a lot more competition. So the existing monopoly providers, the generators and the suppliers, regional suppliers, were broken up, and competition was introduced through competing suppliers. And that relied very heavily on the ability for consumers to switch between competing suppliers. By 2014, there was a well-known report at that time called the State of the Market Report, which basically came out with the focus that it was not working for customers at that point in time. And specifically, that people were locked into contracts that they weren't moving from, that were perhaps 20 or even higher percentage of the cheapest possible supplier that they could be using. So it was a problem, and there were two ways of addressing that. The first thing that happened is that Ofgem introduced a new switching, or is in the process of introducing a new switching regime, which is called the Target Operating Model. It was designed to move switching from from 21-day switching, which is what we are currently enjoying, to next-day switching. And that's due to take place over the next 2 years or so. So that's going to be the first change to try and address this problem. The second thing is they referred the energy industry to the Competition and Markets Authority. So for the last 2 years, there's been a CMA investigation into the energy sector, which actually reported 2 days ago. It was about 2,500 pages of reports, so I don't have a chance to go through all of it. But the bottom line is that there's well, in fact, there's a number of changes which will be rolled out. But as far as we're concerned, there's some interesting ones. The first thing is that there's going to be more tariffs, or effectively more complicated tariffs, with all sorts of discounts and so forth. So that's being freed up. It was closed down, and suppliers were restricted to the number of tariffs they could offer, and that's now being opened up. But that leaves a challenge. How do you know, again, you're back in the world of mobile phones, how do you know you're on the cheapest tariff anymore? So that's the first problem that needs to be solved as a result of that. The other big change has been a recommendation for more data availability. And what the Competition and Markets Authority have recommended is what they're calling a secure cloud data. They don't define it any better than that. But with the idea that people who are not switching energy suppliers are effectively, their data is available for them to be given or shown the benefit to them to switch. It's obviously a little bit more complicated than that, but that in essence is what is going on. And I'll come back to that in a second. The final thing in relation to where we currently are in the market in the UK is smart meters. Which, if you weren't aware, currently about 10% of homes in the UK have smart meters right now. That is supposed to change to effectively all homes in the UK by 2020. So the next 4 years or so is going to be a fairly major rollout of smart metering. And these three things, the change to the switching regime, the exposure of data, and the rollout of smart meter, we see as the sort of the key changes in this market that give us an opportunity to apply blockchain technology and decentralized database technology to this market to the benefit of clients. Okay, so what are we trying to do about all of this? The first thing is we are building a consortium blockchain, private consortium blockchain, so permissioned, which will be an open platform. And the concept is it will be run by suppliers. So suppliers will have, and other energy market participants will have or will be running nodes on that blockchain. They'll be permission to do that, and that will then allow them to participate in this. And this, I hope, recognises the first principle, which is to try and not put the power or concentrate the power within a single centralised monopoly, but to open that We see a platform that operates between the meter, the metering point and the supplier, and one that's going to drive competition. So the other point that we want to try and push is the concept that this platform should be open, that it will be open to participation from competing providers of services. So the concept is a very basic platform that manages the supplier and supply point relationship, but allow you on top of that to offer all kinds of additional services, which we see as competing. So it becomes a catalyst for innovation in that space. And most importantly, that it is also then transparent for the regulators. So that's the innovation. Let me move on and just cover, as I finish off here, what the main things that we're currently working on. Firstly, we have a data capture project which involves optical character recognition using mobile phones, which is one way for dumb meters to be able to collect data, because we can't leave them out at this point, but also interacting with smart meters themselves to be able to pull that metering data in. The second major area that we're currently researching is how you store vast amounts of data. In this case, we're talking about energy usage data, so it's data derived from the raw data, raw meter reading data. How we handle and manage that securely and provide access potentially to people or service providers that would look to analyze or interoperate with that data in such a way to extract additional information. And that is challenging, and I think we've heard a little bit about privacy. In our case, we're looking at homomorphic encryption for this, and we've had some small amount of success in that, but there's certainly a long way to go. Invoicing services, I won't touch on, but that's relating to how you bring the reconciliation of the billing system into this process. The main work that we're currently engaged in is on the actual supplier, or supplier statement. One of the things that we've done, I hope there's going to be a couple more things coming out, but we've tried to release some of these things or open source them. So we've got a .NET API client over IPFS, which you're very welcome to download and get involved with if you wish. We also, I think, were the first people to produce an R package for accessing Ethereum, the Ethereum blockchain, and that's also available on GitHub as well. And I think we're in the process of moving that to a CRAN package. And that's it.
I've seen a demo of a few things that you were doing, but I think you had brought your tech guys with you.
I've got one of them with me, yes.
But do you have any demo of that or any screenshots? Because they were extremely exciting.
Would you like to just come and have a quick chat about what you've been doing on that?
Yeah, so you're talking about the visualization of the meter switching?
Yeah.
So we've kind of cut that out from some of the stuff that we're doing at the moment, kind of go into the actual industry side of it in a little bit more detail. The visualization that you saw was kind of the first prototype that we put together. We were loading up on the order of kind of tens of meters onto like a basic version of the platform. You had customers that came onto the platform, basically created supply contracts between themselves, the meter, and the energy suppliers. And then we've been building some kind of scripts that kind of simulate the switching patterns of various customers. So the stuff that we built before was using some kind of just JavaScript visualization. So we've built kind of like a base app for visualizing some of the data from the blockchain directly, which is what we'll be using in some of the kind of APIs and visualizations at a later date. And that was basically so that we could see what was going on, so that we could demonstrate to people what was going on.
That was absolutely awesome. Do you think, do you have anything available on the website maybe? We can have a look.
There's nothing up at the moment, I'm afraid. It was one of my colleagues who actually put that one together. I was the person who's been working on the R package. So We can put something up on the website, I guess,
We
at some
can,
point.
yeah.
So
Yeah.
if people are interested, then check back or drop us an email and we'll go through it.
This is the Viz.js animation that you
Yeah, you were
saw.
showing a few
Yeah.
things. You're just showing big data with the blockchain and what essentially you have been doing. That was really exciting because, you know, it shows essentially like true, exciting visualization of what actually we do with the data itself and how it is brought into the industry and what can be done with it and how you're using it. So that was so exciting. So I was hoping you had a bit of...
Sorry about
That's okay.
We'll have to put it back in.
We'll have to put it back in.
Yeah.
It's okay, we'll get people excited. I'm sure if you can post something in, that would be awesome.
Yeah, definitely. Yeah, grab hold of us. We'll get to the website. So.
What's the reception been from regulators? Have you got discussions there?
We have, and well, I think I can't really go into too much detail on that. As you can imagine, they're more sensitive conversations, but
They're interested.
they're interested. Yeah, I mean, because it gives them insight into what's going on and a degree of control that they don't currently have. I mean, we didn't make there's one really simple thing which I think people will be astounded here to discover. That the government has an initiative called My Data, which basically says that, you know, if you, whether it's your bank account or whatever, if it's your data, you should have the right to have that and to have access to it. And it's pretty obvious that it'd be quite nice, you know, if I'm an energy consumer, I'd like to know what data about, let's say, my meter readings that my energy supplier is holding, because that allows me then to decide which is the cheapest energy supplier if I'm doing it myself. Amazingly, that's limited to, even though it's law, it's limited only to the larger suppliers. And I found on looking one of the websites recently, you've got to have been their customer for at least a year, and they'll only update it for you once a year. I mean, it's insane. So this is the kind of thing that we want to bring and make available. Yes.
What's the motivation for the big suppliers to move to the Electron platform, considering you'll open up more competition for smaller suppliers?
So what's the route to market for this, essentially? Well, first of all, smaller suppliers are around about 15% of the market and clearly have an appetite for having a bigger stake. So our initial approach is to the smaller suppliers, and they can see the benefits that this will bring them in the sense it becomes a level playing field. They can compete equally with the larger suppliers. So getting them on board will be the first step. And then we expect that will then push the larger suppliers. So that's one mechanism. Another mechanism, I guess, is we can mimic their contracts anyway. That we know what their tariffs are, we know which regions they're supplying it with those particular tariffs, we can mimic it. The fact that you can't make it available on our platform means that it's more hassle for them, they might as well make it available.
Is part of it also regulator buy-in, if you can promote this as a solution?
Yes, I mean, to be honest, we haven't had that conversation where we've said get on board yet, but that will come. And I think we've got a great group of shareholders who are extremely well connected in this industry, and we don't think we're going to have a problem knocking on the right doors to have that conversation when the time comes.
Do you envisage this will permit you to move, change providers constantly, or how does this compare to U-Switch in my mind? So I use U-Switch, I change annually. Does this permit you to change multiple times, or will you just be allowing it to change constantly?
Well, what I've talked about is a platform that has the base data that is required to map a particular supply point, your meter, to a particular supplier, which is the basic information that's required prior to doing any kind of switch. When I talked about it being a base layer for new and innovative services, one of those innovative services is something that, for example, would look at all of the available tariffs in the market, understand what your particular consumption pattern profile was, and say, you know, you really ought to switch because there's a cheaper supplier over there. That's currently a function that's fulfilled, as you rightly say, by the price comparison websites. I would anticipate, if we're successful in what we're trying to do here, is that they would have to have an offering that provided similar functionality and interacted with a platform like this.
What's the granularity of the data you're collecting? How many data points are you getting per meter?
Well, it depends on the, if you have dumb meters, then typically, it's as often as you can pick that up, maybe once a month there'll be some kind of estimated reading. Smart meters will generate meter readings every 15 minutes or half an hour.
You're storing that on the Ethereum blockchain?
No. No, that wouldn't work. And in any event, really, it's not a transaction. It's the blockchain piece of what we do is a transaction. So there's a transaction, for example, when I switch from one supplier to another. That's something I want to keep on the blockchain. But what my energy consumption usage and pattern is not something I need to store there. But we do need to have it potentially capable of access to services which can talk to a blockchain and talk to a database of some form that has this data. And that's how you would be able to do the kind of calculations that you were thinking of. Yep.
Apologies, I'm struggling to understand the opportunities in commoditized industries. Could you explain again?
So the opportunities of what?
In commoditized industries.
In commoditized industries.
Yeah, like electricity supply. Please could you explain what is the blockchain in your application?
Right, so
Can you repeat the question?
Yeah, the question is, why do you need a blockchain for all of this? Is that
Yes.
Okay. Why do we need a blockchain for all this? Why don't we just put everything in a database? Okay, well, a database is run by one party typically. You don't tend to have consensus databases. So the main thrust of this is to say that effectively all of these suppliers, good guys, I'm sure they are, you can't trust them. Not because they're necessarily dishonest, but because maybe their systems aren't working. Their billing system hasn't functioned properly, as has been the case with a couple of suppliers recently. There are mistakes being made. Why would you provide a monopoly to a particular person to operate a system when it's more efficient to have a mechanism that there's competing, for example, consensus in the development of consensus on a blockchain? It's cheaper to do that. I could go on. Bankruptcy. The various other things that I put on that list really are reasons why it makes sense to put this on a blockchain. Well, look at what the current situation is. That's what you're trying to get away from. Oh, sorry. Are we okay?
Can we make last question?
One last question.
You said that building a consensus database among the various involved parties is harder than putting it on blockchain. But fundamentally, when you are putting the data on the blockchain or asking the various providers to come on the blockchain, you are actually empowering people to get access and have administrative rights over that data, isn't it?
Well, do you mean they have some special control?
Yeah.
Well, that's the beauty of the blockchain, is that nobody has this right to control things. In our case, Ofgem will have an authority to designate they do already, your license as a supplier, your license as an energy broker, or whatever it is. But these parties are not in control individually of the whole network. As a group they have a consensus purpose, but any one of them could go off, disappear off the network, or switch off his computer, or be obstructive, or whatever it is, or cause problems, but the thing continues without them.
Which is as good as a shared resource.
Well, how are you sharing the resource in this case?
It's a shared resource, it's a shared database which is available to everyone. I am not available, but you are, and you are working with it. And I own my data.
In the sense of that's what a blockchain, you can characterize a blockchain in that way. Although perhaps you could add the fact that in the case of a blockchain, you could have Byzantine nodes which don't try to play according to the name according to the game.
Well, I think the difference with the database, the shared database, is you have, unless if you replicate the database in different ways. I don't know if you're talking about infrastructure, if you're talking about availability, but you know, I mean, blockchain essentially is Napster without a central server. So to put it very simply, it's like peer-to-peer system without a central command. So nobody can raid the place and switch off the main central server. So it's essentially the Excel spreadsheet shared with everyone, available everywhere. As long as you have 2 participants, you're done, that's it. Even 1, but you need 2 to have a blockchain that makes any sense.
Maybe we can take it.
Sure.
Okay, thank you very much.